Every week we ask wise guy Matt Sellens we ask him to come in and answer your questions. He also says, hey, I'll answer your questions. So this week he's actually doing that. This week's question comes from the 5th graders at Yankee Ridge Elementary in Urbana. They ask, why are laser beams red? Matt, why are laser beams red?
Oh, we'll talk about that. But, you know, the reason you think laser beams are all red is because you get these laser pointers for $2 at the gas station,
right,
and they're all red. But as I just showed, here's a laser pointer that's green. And it's actually much brighter, and it's very cool how this thing works. So we're going to describe how these lasers work in a moment. But first we have to take a step back, and we have to explain how light is produced to begin with.
Okay.
Okay, now, in our everyday experience, there's two kinds of light that we usually see. We see sort of light bulbs, incandescent lights, and we see fluorescent lights. And they work very, very differently. And so the lasers work a little more like fluorescent lights in a way, and I'll describe that. But let's look at a regular incandescent light bulb first. I'm going to turn this thing on, and it's quite bright, right? And so if we can sort of center that, and what I'm going to do is put in front of this thing a diffraction grating. What this thing does is it's like a prism. It just splits the light up into colors. So what you'll see now when you look at this thing is that you'll see the white light, which is what comes out of this, is really a spectrum that contains all the colors, so all the way from violet all the way up to deep red. And so that's kind of cool. Now, and that's the kind of light you get when you get something very, very hot. There's a filament in here that's thousands of degrees hot. It's glowing white hot, sort of like the surface of the sun is, and that's why the sun is kind of the same color as that thing a little bit.
I need to stop looking right at it.
Right, it's pretty bright. Let me turn that one off, and let me instead put in front of there, and I have to unplug and plug back in because I forgot to bring my extension cord. So here we go. Here I have a discharge tube. Slide that over here so that it's sort of in the middle. You can see that. Hopefully what you can see now, if you dim the lights, there we go, is instead of having now sort of a smear of colors, you have lines. You see different colors that are different distances away from that central line. And so what happens is, what this shows is that inside a gas discharge tube, you have just very specific frequencies of light that are produced. That's because these are produced in atomic transitions. Okay, so these, the gas inside this tube, which happens to be helium, has certain atomic transitions that produce very specific colors of light.
So it depends on what the light is going through, essentially.
It depends on what it's produced. We can bring the lights back up again. So what happens in discharge tubes like neon lights and so on, you have atoms that have atomic transitions that give off light, but the atoms don't have to be hot. They don't have to be thousands of degrees like a filament of a light bulb. And so that's one way to produce light. That's sort of cold light in a way.
Okay.
And then there's the hot light, which is the light bulb. These bulbs get very hot. You can't touch them or you burn your fingers, and you can cook with them, right? There's easy bake ovens when you were a little kid.
Yeah.
Okay. And so the way that lasers work is more like the way that these things are, and we'll describe that now or next time or when we come back in a minute.
We have about 30 seconds to go.
Okay. So what we can show then, actually, let me get this out of the way here, is that the way that these lasers operate, and we'll come back and we'll do this a little more when we get back.
Further.
Right, is just like in this discharge tube, there are atoms in here which get excited into a higher excitation level, which then de-excite and give off light of a very specific color. And the red ones give off red light because that's the way those atoms are arranged in this material. And the green one gives off green light for a very interesting reason, which I'll get into.
Okay. All right, that's all the time we have. So we are answering why laser beams are red, not necessarily always red, and we'll get back to that in just a bit. Right now, 6:53.